Good morning to all. Myself, Dr. Redya Jadav, working as a assistant professor in CSC department at Marri Laxman Reddy Institute of Technology and Management. My subject name is here formal language automata theory. Now I am discuss about what is the automata theory. Before going to draw the transition diagram, what are the terminologies are used? Then I want to explain one by one. After going through this chapter, you should be able to understand what is the alphabet, what is the string, and what is the language. What is the finite automata? What are the different types of finite automata? And conversion of NFA to DFA, conversion of NFA with epsilon moves to NFA without epsilon. Now, what are the terminologies used in that? Find here the formal language automata theory. First one is the alphabet, second one is the string, and third one is the language. Alphabet is a set of symbols. It is a symbols. It is denoted by here the sigma. It is a finite and non-empty set of symbols. Whatever is the sigma, whatever if you want to take that AB, sigma AB are the input alphabet, or whatever you want to take here numbers 0 and 1 are that input alphabet. Example. Sigma is an alphabet containing the 26 characters used in the English language. Or whatever you can take, here that sigma is either you can take the 0 or 1 only. English letter you are going to use in small case letter here that A to Z because of 26 character in English language. And x equal to 0, 1, it is that alphabet. And whatever here that sigma you can take here that 1, 2, 3, 4, so on. No, it's not is a alphabet. Or whatever Z equal to, here the open and close braces. Here it is not a alphabet because of it is a empty. Next, what is the string? As far as the C language, string is a collection of characters. So collection of character. But in this, string is a finite sequence of symbol from that alphabet only. Whatever I want to write, here the sigma input alphabet is the AB. I want to write the string here that AB, it is a string. But here the string is denoted by that, here the W, string is denoted by the W. String is denoted by the W. W equal to AB. It is the finite sequence of symbols from that input alphabet. Or whatever I want to take is a sigma input alphabet are the 0 and 1. Whatever you want to take the string, here with the combination of zeros and ones, 1 0, 1 0, 1 1. So whatever here that it is a sequence of symbol from this input alphabet only. But here given that example, XYZ is a string over the alphabet sigma AB A to Z. The empty string is the null. So whatever W is here that epsilon. What is the meaning? It is that empty string. It is an empty string. Or whatever you want to take, it is a W. Here that with the combination of 1 1 1 0 0, it is that string. From that over the alphabet, over that numbers 1 1 or 0. So what is the length of this string? So if you want to write the language, here the combination of 0 1 0 1 1 0 1 1 triple 1 or double 1 0. It is a string. Now you can determine that length of this string. How? So the string is denoted by W. If you want to determine the length of this string, the mod W. Mod string is here I want to take triple 1. String is the triple 1. What is that mod W mean? Length of the string is the 3. Or whatever you want to take that one more example, W 1 0 1 0 1 1. So whatever mod W mean, what is the length of the string? How many symbols in that string? 1, 2, 3, 4, 5, 6. The length of the string is 6. It is denoted by mod W only. So W equal to ABCD. The length of the W is mod W. How many characters in that string? ABCD. 1, 2, 3, 4. Length of the string is 4. or whatever you can take that n equal to 101, whatever. Here that mod n, length of this string is 3, or whatever empty. Here the epsilon is there. It is a empty string. There is no string. Mean the length of this string epsilon, length of this epsilon or length of string is 0. This is the length of this string. String is collection of, here a finite sequence of symbols. It is denoted by sigma. Here it is a w. And if you want to determine the length of this string, so it is a mod w only. Next, concatenations. In the string, we have to use concatenation, means joining of two strings. But here, if W1 and W2 are the two strings, then concatenation of W1, W2 with W1 is a string. It is denoted by W1, W2. In other words, we say that W1 is followed by W2. Whatever you want to write that mod W1, W2. Simple, right? Mod W1 plus mod W2. The joining of two strings. Next one is the prefix of a string. A string is obtained by removing the 0 or more trailing symbol is called as a prefix. I want to take here that string is the ABC. What is the prefix of the string? I want to write A. Yes, that is the prefix of the string. BC, that is the prefix of the string. And ABC, this is also prefix of the strings. Next one is the suffix of a string. But here, suffix, it is a string obtained by removing 0 or more leading symbol is called as a suffix. If you want to take that string is, whatever string is, ABC. Here, what is the suffix of the string? So, whatever C, BC, then ABC. But here, suffix of a string and prefix of a string both are not equal. Remembering this one. Suffix of a string and prefix of a string, whatever A, C, B, C, whatever both are not equal. Suffix of a string or prefix of a string both are not equal. Next one is the language. What is the language? Here the simple say that language is collection of, it is a collection of strings. Collection of strings. So it is denoted by, here it is denoted by L. It is denoted by L over the sigma. Whatever I want to write, the sigma is the input alphabet is the A. Whatever you want to write the language with the combination of zeros and ones. A is a string, B is a string, AB is a string, B is a string, ABA is a string, BBA string, or AA, BB, whatever, so on. It is a combination of input alphabet that is called as a string. Collection of string is called as a language. See that a language over sigma, L over sigma is a subset of sigma star. That is a collection of string. That is a collection of string over that alphabet. Whatever you take that alphabet is the sigma A comma B, or whatever you can take that sigma, you can take the sigma AB. That sigma is the input alphabet. Sigma is, here the sigma is 0 comma 1 input alphabet. By using with the input alphabet, we want to write the string. Collection of string is the language. It is a 0 or 1, 0, 1, 1, 0, 1, 1, 1, 0, 1, 1. Here a 1, 0, 1, 1, 0, or 0, whatever you can write that. This is the language. Language is the collection of strings over that alphabet sigma. Or you can take the sigma, the input alphabet is the AB. You can write here a combination of, language can be write the combination of A's input alphabet, A and B, so on. But pi and epsilon are the languages. The language pi is is undefined, similar to that infinity. But here that epsilon is the empty box. The length of the epsilon is 0. Length of the pi is, there is no length. That here that length of the epsilon is that 0, that is the empty box. That language without any string, that is the epsilon. Now you can take that example. Here the first example given, the over the alphabet 0, 1 mean the sigma. First example, see that first example. It is a sigma over the alphabet sigma. Here a 0, comma 1. Now you can write that language L1 with the combination of 0, 1, 0, comma 1, 0, 1, 1, 0, 1, 1, or 1, 0, 1 with the combination of zeros and ones. This is the collection of string is called as a language, that is the L1. Next one is the L2. Second example, L2, the sigma is only 0. You are going to write with the combination of zeros only. L2, it is a empty, you can take that epsilon, but empty string. Then 0 or 0, 0. Any number of zeros you can write. So on, that is that L2. Or sometime you are going to write the language. Here that I want to write the language. I want to write the language in the push down automata or Turing machines. But here given that L3, third language, here a 0 power 1, 1 power n, and 2 power n, such that n greater than or equal to 1, it is also language. Or whatever you want to write, here that a power n and b power n, such that n greater than or equal to 1. But in case if you want to take that n equal to 1, a power 1 and b power 1, that is a string, one string. If you want to take n equal to 2, a power 2, b power 2, mean double a, double b. In case if you want to take n equal to 3, a power cube, 3 b power cube, take triple a and triple b. This is that language. That is the third way of language. Next one is the clean closure of a language. It is the most important in the formal language automata theory. Clean closure and positive closure. What is the clean closure? Let L be a language over that alphabet sigma. The clean closure of L is denoted by L star. L star. What is the L star? L star means here the clean closure of the language. Set of all strings including epsilon, then this is called as a clean closure. But a set of all words over the sigma including epsilon. How to write? Here that clean closure, epsilon, and set of strings. Then after you are going to write the set of string. What I said, the clean closure of the language, it's contain the set of strings including the epsilon. Then this is called as a clean closure. Here L star, set of all words over the sigma. Mean the length of the 0. Here that we know that I want to take here the sigma, here the 0, 1 with the combination of 0, 1. I want to write the clean closure. Here that epsilon and 0, 1, 1, 0, 0, 1, 1, 1, triple 1, triple 0, or 1, like this. The length of the epsilon is 0. Remembering that's why written that word of the length is 0 initially. The word of the length of the string is 1. It is a 1. Length of the string is 1, 0 means it is a 2. And here that 2. And it is also 2. This triple 1. The length of the string is 3. So that's why it's done. L power 0 means length of the string is 0. L power 1, length of the string is 1. L power 2, length of the string is 2. And I mean the string is contained of 2 characters. from that alphabet. L power 3, the length of the string is 3, but the string is contained that 3 symbols over that alphabet. Positive closure. This positive closure, it can be denoted as sigma plus. It can be denoted as sigma plus. If sigma is alphabet, then positive closure of sigma is denoted by here that sigma plus. What is the meaning? Sigma plus mean sigma star, clean closure minus epsilon. Here the clean closure, here the set of strings including that epsilon minus epsilon. Epsilon is cancelled. Here the positive closure mean it's contain that only set of strings. Contain that only set of strings. So whatever you are given, sigma plus positive, here that positive closure equal to, here that clean closure minus epsilon. Here the set of all words over the sigma excluding empty string epsilon. But I want to take here the example. Here the example is given. Sigma is here at that 0, comma 1. 0, comma 1. But here the positive closure I want to write. Positive closure mean positive sigma closure. Here positive clean closure minus epsilon. What is that sigma closure? Set of strings including with the epsilon. Here the positive closure equal to set of string epsilon, clean closure epsilon 0, 1, 1, 0, 1, 0, 0, 1, 1, or here 1, 0, 1, 0. So whatever you can write the set of strings minus epsilon. Epsilon cancel. The positive closure is it's contain that only set of strings 0, 1, 1, 0, 1, 0, 0, 1, 1, or 1, 0, 1, 0, whatever you can write. But it's is that, what is that? It is a set of strings. It is a set of strings excluding epsilon. But here that clean closure mean set of strings including that epsilon. Positive closure mean here the set of strings excluding the epsilon. All of you understood or not? Next. Finite automata. It is the most important. So finite automata is also contain input tape, finite non-empty set of states, input alphabet, read-only head, and transition functions. What is the use of transition function? It is changes that configuration, mean it moves from one state to another state, and it's contain the initial state and also contain that final state. So here that finite automata consists of a finite memory. It's required the memory is called as a input tape. This is the here the memory. Mean the input tape. In the input tape, we are going to store the strings. Then explain can. Here that finite non-empty set of states and input alphabet. Here the sigma. And here the reading head. It read that only one symbol from that only one cell. And transition function that is called as a delta. Transition function is used to move from one state to another state. It's moving from one state to another state. An initial state, but transition diagram is contain that initial state as well as that final state, that is the double circle. Finite here final state and a finite non-empty set of final states only. Final state represented here the initial state can be represented as circle with that arrow. The final state can be represented as a double circle. Now, the model of finite automata, see the diagram. In this diagram, what are that? Here the finite automata contain that input tape, reading head, and finite control, and initial state and final state. But here that Input tape. This is the input tape can store that only strings A, B, B. Input tape can be divided into that number of cells. Each cell contain that only one symbol at a time. But here the input tape, the leftmost cell, it is a leftmost cell. It is a rightmost cell. The leftmost cell is contain the one symbol. It indicates that beginning of the input tape. And the rightmost cell, it's contain the dollar prompt. It indicates that end of this input tape. Here the leftmost cell is contain that one symbol. Then is that one symbol. It indicates that beginning of the input tape. But reading head is there. The reading head, what is the role of reading head? Is read that only one symbol from that only one cell. Either it can move left to right, or it can move right to left. It's possible in the both ways, left to right or right to left. But in this one, it's not possible. It is reading is possible, but we cannot write into that input tape. Reading head is read that single character or single symbol from that input single cell. Either it can move that left to right or right to left, but cannot read that write the symbol into that input tape. This final control, here a final control, you find that next step of the configurations. Mean it is a delta, it is a transition function. Initially, you want to take that initial state is the Q, and the reading head read that I want to take ABB, ABA, A. It goes to that, find out that next state. But Q naught is that current state with that current input symbol. It goes to that next state. It is identify that final control. This is the concept of finite automata. But here written, the input tape divided into the number of cells. Each cell contains the only one symbol from the input alphabet. One symbol, this symbol is used to leftmost cell, and dollar prompt one more symbol is the rightmost cell. Here that this symbol indicates that beginning of the input tape. One more symbol at the right cell, it indicates that end of the input tape. But read head only one symbol on the input tape, and final control controls the next two configurations. It's find out that next state, current state with that current input symbol, it goes to that next state. But reader here that reader head, here that head can read either left to right, or either can from that right to left. But it's you cannot write that symbol into that input tape. Cannot write that move, it cannot move backward also. Finite automata cannot remembering in previous read symbols. This is the major limitation of finite automata. Next one is, it is the most important. It is the most important in the finite automata. The finite automata can be divided into the two categories. What are the two categories? Here that DFA and NFA. Deterministic finite automata and non-deterministic finite automata. Finite automata can be divided into the two types, DFA and NFA. DFA stands for deterministic finite automata and NFA stands for non-deterministic finite automata. Sir, what is the deterministic finite automata? Here the deterministic finite automata, it is a finite automata is a collection of tuples, but the DFA can be defined as, is it a collection of tuples? How many tuples? 5 tuples. 5 tuples. What are the 5 tuples? M equal to Q, sigma, delta, Q naught, and F. Here that DFA, it is a collection of 5 tuples. What are the 5 tuples? Q, sigma, delta, Q naught, and F. Sir, what is that? Here that, what is that Q? Q is a set of states. Then explain with that example also, with the transition diagram. Sigma is, it is the input alphabet. Delta is a transition function. Major role of delta is a transition function. What is the advantage? What is the use of transition function? Transition function is used to move from one state to another state. And Q naught is that initial state of the in transition diagram. And F is the F. F is, it is a final state, that is belongs to that Q. Here the initial state, it also belongs to that Q. And final state, it is that belongs to that set of states. But the transition function is the most important in the NFA and DFA. Mean Q into sigma goes to that Q only. This is that major difference in between that NFA, DFA and NFA. Q into sigma goes to that Q. Q means current state. Q means it is the current state. Sigma means it is the current input. Current state, with that current input, it goes to that next state. Next state. So that's why here the Q is that finite set of states, including with that non-final state and final state also. Sigma is that input alphabet. Transition function is that it is used to move from that one state to another state. Q into sigma tends to that Q. Q is the current input, current state. Sigma is the current input. It goes to that Q, mean next states. And Q naught, that is the initial state of the transition diagram. F is that final state of the transition diagram. Then I want to explain with that simple transition diagram. Then I want to explain DFA with simple transition diagram. See the transition diagram. Transition diagram. But here the Q naught is the initial state with that arrow mark. Then Q naught with that A goes to that one more state Q1. Q1 with B goes to that one more state Q2. Here that Q2 is contained a double circle, mean it is a final state, and it having that self state here at 0, 1. But here the transition diagram. But as per as that DFA, what is the Q? We know that here that it can be defined, it is defined as, it is a collection of tuples. How many tuples? 5 tuples. Q, sigma, delta, Q naught, and F. But delta is a transition functions. Mean it's generate that only one path from current state to that next state only. But it not goes to that multiple path. If it is goes, it generates that more output, multiple path. So that is called as a NFA. But here that Q, set of states, how many state in that transition diagram? Q naught, Q1, Q2. Q naught, Q1, and Q2. There are 3 states in the transition diagram. But what are that? Sigma. Sigma mean what I said. Sigma is that input alphabet. What are the input alphabet are used? Q naught with the A goes to that Q1. Q1 with that current state is the Q1. B is that input alphabet goes to that Q2. Q2. But here that sigma is that 0, 1. But delta, Q naught, what is the Q naught? Q naught is the initial state. And F is when the here that any one of the state having the double circle, then it is called as a final state. Final state is the Q2. But I want to define the transition. Delta is the transition function. How to define the transition function, which maps as Q into sigma goes to that Q only. Q is the current state. With that current input, it goes to that next state only. As per this example, delta is a transition function. Current state Q naught with that A. Current input is the A. It goes to that. Here that Q naught is belongs to the Q. Sigma is belongs to that input alphabet. Here the input alphabet. And here that it goes to the state Q1. That is also belongs to that. Q1 is also belongs to that Q only. And there is a only one path from current state to next state with that current input symbol. If you take this, here that Q0, one more is Q0 with that A. It's not possible in the DFE because of it generated that multiple path. How Q0 with the A, Q1. And here a delta, Q0 with that A, it goes to that Q2. There is multiple path. Current state with that current input, it goes to that multiple path, Q1 and Q2. Then it is called as a NFA. But here that there is only one path from the current state to next state, then it is called as a NFA. Thank you, one and all.